Okay, so this is chapter 19 quiz. First one, X and Y are two initial uncharged metal sphere. Okay, so this is uncharged sphere. So this is X and Y. Okay, so they put together and stand. This is the interior stand. Okay, like that. All right, and then a charged object put close by. So this is positive. Okay, and then what will happen? When you put a charged object close by. Okay, because those are conductors, they have a lot of free electrons. Free electron will be attracted to this side. So leave the other side positive charge because you lose free electrons to this side. Okay, and then with this guy stay there, then you separate them. Okay, so just like that, you separate them. Okay. And then what will happen here is they will separate them. So this guy's still there. Okay, so this is X, this is Y, you separate them. Here you still have negative charge here, this and positive charge, right? And then next step, you remove this away. Okay, so, so you have negative charge left on this one, positive charge left on this one. All right, so the first question. All right, second one. Second one is three charges, right, on a square. So this is a square surface. You have a charge, positive Q, and positive Q here. All right, so you put in the middle, you put another positive charge. Ask you net force acting on the charge on this guy. Okay, net force. All right, so direction of net force. All right, so let's see. This charge, you have 3 force surrounded by this charge, right? So you have to calculate, talk about net force, right? So net force equal to, you look at the force from everybody and then you add together. Because forces are vectors, you have to add them together in a vector way. All right. So force from this charge on this charge, right? So positive charge repel. So force from, we call this Q1 will be on the line, link them together, push away. All right. Force on Q2 will be link them together, push away, right? Force on Q3 on this charge will be link them together, push away. All right, now you have, this is F1, F2, F3. Add them together because F1 and F3, same magnitude, opposite direction. Why is the same magnitude? Because amount of charge is the same, right? Okay, and the opposite direction. So they basically cancel each other, F1, F3. So cancel this guy, right? So only force left here is F2. All right, so net force will be in this direction, in B direction. Okay, so number three. Two tiny particles have charges 20 microcoulomb and negative 8 microcoulomb are separated by a distance of 20. So here, this is 20 centimeter. So this is, assume this is a 20 microcoulomb. This is negative 8 microcoulomb. Okay, 20 centimeter, this is equal to 0.2 meter. What are the magnitude and the direction of electric field midway between those two charges? Okay, so midway be here, right? Ask about electric field. Okay, so you have to look at electric field. We call this Q1, this is Q2. Electric field due to Q1 and Q2 at this location. All right, so electric field, here is the equation, right? So E, magnitude-wise, equal to KQ R square. Okay, so this is electric field. However, if we talk about net electric field, equal to E1 plus E2. Okay, at this location, electric field due to Q1 and electric field due to E2, you have Q2, you have to add together, right? So electric field due to Q1, you see Q1 is positive at this location, right? So push away. So this is E1. Okay, so this is electric field due to Q1. What is the magnitude? So E1 equal to K. Q will be 20 times 10 to the negative 6. Okay, Coulomb, right? And what is distance? Distance here is half of a 20 centimeter, 0.1 meter square, right? All right, let's look at E2. So Q2 is negative, so electric field due to Q2 will be towards Q2, right? So this is E2. You see that? All right, so what's the magnitude of E2? Same thing here, right? So magnitude is E2 equal to K. You see you have an absolute sign here. So this is 8 times 10 to the power negative 6, right? And divided by 0.1. Distance also 0.1, right? Distance. And then you just add them together because they are in the same direction. So point towards the net electric field, right, will be towards the negative charge first, and the magnitude, you just add this one and this one and this one together. Okay, use a calculator, you can figure this out, right? All right, number 4. Number 4 is the electric field at a point charge, 2.8 centimeter from a small object, okay, at a point, right? So this is a small object, we don't know. The electric field at a point, 2 point, assume this is this point, right? 2.8 centimeter. So this is equal to 0.028 meter, all right? From a small object points towards object, point towards object, okay? So this electric field with a strength, all right? 180,000 Newton Coulomb. What is object's charge? Well, first, this guy must be a negative charge, right? Because point towards. And the magnitude, use this equation, right? Use this equation, electric field 180, okay, equal to K, 8.99 times 10 to the power of 9, and Q, right, you don't know. Distance 0.028 square. Okay, so this equation, find Q. You see, find Q. Basically, this guy times this guy divided by this guy. Okay, so find Q. And this Q you get here is a positive value. Okay, because you're looking for magnitude of electric field. And then because the direction tells you the sign of this charge, so towards this object, which means this must be a negative charge. Okay, so plug into here, you get either C or D. Actually, it should be, well, just like you use a calculator, find this one. Number 5. Number 5 is, okay, so as shown in the figure, for charge Q is the middle way between Q1 and Q2. And so this is the middle way, right? So this is the Q, charge Q. Q is negative 7.5 nanocoulomb, okay? What must be the charge Q1 so that Q2? So this is Q1 so that Q2 here, Q2 middle way. So this is 10 centimeter, right? Equal to 0.1 meter. Same thing here, 0.1 meter. And Q2, okay. So that charge Q2 remains stationary. All right. What's the meaning? What's the meaning of a stationary? Stationary means, you put a charge Q2 here, Q2 will not move anywhere, which means that the force on Q2 is 0. All right. So talk about net force. Net force will due to, you see, Q1 on Q2 and capital Q on Q2. Okay, so look for the net force equal to 0. You see, net force on Q2, right, equal to electric field times Q2. Okay, so net electric field at this location times Q2. If this guy is 0, which means E is 0 at this position. Okay, so now, well, how to make a 0 electric field here? Okay, so 0 electric field means electric field due to capital Q. You see negative charge, right? Electric field go to this direction, right? So this is, we call this E, right? Capital Q. And plus electric field here, Q1. Well, because this electric field point to the left side, right? So this Q1 must generate electric field towards the right side. Okay, and so Q1 got to be positive charge first, right? And the magnitude of electric field due to those two charges will be same. Okay, direction opposite. Okay, so magnitude of the electric field due to Q1 at this location equal to K Q1 R squared. What's the distance? You see, distance of Q1 to this location is 0.2 square, right? Equal to K Q. Distance here is 0.1 square, right? So you plug 7.5 nanocoulomb here, nanocoulomb, right? K and K cancel, and then you figure out what is the Q1 magnitude, right? Q1 magnitude will be, just like whatever, times 0.02, right? So Q1, so this is 7.5 nanocoulomb times this square 0.04 divided by this square 0.01, you see? So you have 4 here, right? 4 times 7.5, 30 nanocoulomb, right? Okay, so that is Q1, and Q1 will be positive charge. Number 6. Okay, 2 point charges each experience 1 Newton electrostatic force when they are 2 centimeters away. Okay, so 2 point charges, right? So the force doesn't matter, it's a repel or attractive, right? So you see force equal to K Q1 Q2 R square, right? All right, so this is 2 charges, and ask you if they are moved to a new separation 8 centimeter. Okay, so this is the first separation. Second separation is 8 centimeters. So increase to 8 centimeter, which means R increased by 4 times, right? Okay, so what is the magnitude of the electric force? You see here, so Q1, Q2 is the same, but this one increased by 4 times. 4 square is 16, right? So the force will drop 16 times. Okay, so here is 1 Newton. Drop it 16 times 1/16 Newton. That's the whole meaning. All right. So next one, number 7. Number 7, 2 stationary point charges Q1 and Q2, right? Q1 and Q2 shown in the figure along with a sketch of some electric field lines. Okay, so look at electric field lines, right? We know electric field lines get out of positive charge, right? Get out of a positive charge. So this is a positive charge, and get into a negative charge, right? So we can tell from this, we can tell Q2 is positive, Q1 is negative. And also, you count the number of lines coming out of Q2 will be much more than number of lines get into Q1. Okay, which means Q2 amount is larger than Q1 amount. and Q2 is positive, and Q1 is negative. Okay, so we look at Q1 is positive, wrong. Q1 negative and Q2 is positive. That's right. Magnitude are equal. Okay, actually, magnitude of charge proportional to number of lines get into or get out of this charge. Okay, so Q2 is much bigger than Q1. All right, so Q1 and Q2 have, no, it's not. It's Q1 positive, Q1 is negative, Q2 positive. Okay, so that's right. Okay, so magnitude of Q1 is less than magnitude of Q2. Okay, so C is right. Number 8. Okay, number 8. All right. Two tiny particles having charge of Q1 of 7 1 coulomb and negative 1 coulomb are placed along the y-axis. Okay. 7 is 0, right? So the origin. Okay, so at 0 location, you have 7 microcoulomb. And the other charge, okay, so this is a 40 centimeter, basically 0.4 meter. You have negative 9 microcoulomb. Okay, so where must a third particle be placed along the y-axis so that it does not experience any net electric force? Okay, so basically, where to put the third charge, right? Net electric force, right? Electric force equal to Q, whatever Q, right? Times the field. If this is 0, which means the field is 0. So basically, on y-axis, you find a location so that electric field is 0. Okay, so you see 9 microcoulomb, 7 microcoulomb. So because they are opposite charge, so you find a position so that the net electric field is 0. Okay, so position won't be here because you see this position close to negative charge, far away from positive charge. So you cannot cancel each other because you see, assume here, right? So field due to negative charge will go this direction. Field due to positive charge will go this direction. Okay, so this field will be bigger than this field because this one is close to negative charge. Field equal to KQR squared. All right, so this won't happen at this location. So how about somewhere in between? Due to negative charge, field here. Due to positive charge, field here, right? So add on, you cannot make 0. So must be somewhere here, right? Somewhere y is a negative value. So this is a negative coordinates so that field due to positive charge go this way, field to negative charge go this way. Okay, so they can balance out. All right, so let's see. Assume this is the y coordinates. Field due to positive charge, K, 7, R. You see this is 0, this is y, right? So y squared equal to K, 9. Remember you have a opposite sign here. 10 to the negative 6. Distance. So you see this is the y, right? So this is 0.4. Distance is 0.4 minus y squared. Okay, so the coordinates, right? Distance between 2 points is, you see, one is y1, one is y2. The coordinates distance between those two coordinates were y2 minus y1. That's a distance. Okay, all right. You see 0.4 and y. And you just do the calculation, negative 6, negative cancel, right? All right, so what do? So basically you solve this equation, right? So 0.4 minus y squared 7 equal to 9y squared. And you find it. And remember y is a negative below 0, okay? So just plug in, right? And you can find either A or E. Actually, E will be your answer. Okay, all right. So that's the first research quiz for chapter 19.